Now, what is a tangent? A tangent is a straight line which touches the circle at a point. And the point, we will call it the point of contact. And as shown, it's this red dot. This red dot is the point of contact. There is also a properties of a tangent that you should know, that is a tangent to a circle is always perpendicular to the radius drawn through it, which is as shown, the center of it, O, and this is the radius, and they are perpendicular to each other. However, here is something that you should pay attention to, that is a second. This is something entirely different from tangent. Second is a straight line cuts a circle at two distinctive points. And the length within it, this area, we will call it a chord. Be very careful to distinguish between chord, second, and a tangent. Moving on, we'll be looking at the properties of two tangents to a circle from an external point. And as shown in this diagram, CA and CB are two tangents from an external point of C. And CA is equals to CB. See the orange stripes representing that they have the same length. And the angle ACO and the angle BCO are the same, and both of them are equals to the angle of X. And the angle of AOC and BOC are the same, and they are equal to Y. And the angle of OAC is equal to OBC, which is 90 degrees. And lastly, the angle of AOB plus ACB is equal to 180. And these are all the properties you should know about tangents before attempting a question. And therefore, from this diagram, it is safe to conclude that the triangle of AOC and the triangle of BOC are congruent. Here is an example on tangents to a circle. In the diagram, ABC is a tangent to the circle with a center O at Q, and CST is a straight line. Now the question is, what is the value of K? Now we'll move on to the solution one by one. Firstly, we would have to look for the angle OBC. And clearly, the angle OBC equals to 90 degrees. And the reason behind it is because the line AB and the line OB are perpendicular to each other. And moving on, we'll look at the angle of SOB, which is equal to 2 times 40 degrees equals to 80 degrees. And the reason behind it is because the angle at the center equals to twice as much when the angle is at the circumference. And moving on, lastly, we'll be looking for the angle OSC equals to 360 degrees minus 90 degrees minus 30 degrees minus 80 degrees equals to 160 degrees. Thus, the final answer of K is equals to 180 degrees minus 160 degrees equals to 20 degrees. And that's the answer. Moving forward, we'll be looking at problem solving. And problem solving in circles will involve three ways. And the first one would be the properties of tangents, which we have looked at it earlier, and Pythagoras theorem. And lastly would be trigonometric ratio. which is what we'll be looking at after this. The following question is an example that require you to use all the three aspects mentioned to solve the problem. In the diagram, CB and CA are tangents to a circle with center of O, and OA equals to 4 cm. And the angle of ACB equals to 80 degrees. Calculate the angle of ABC. In the triangle of ABC, the angle of ABC equals to the angle of BAC, due to the reason that CA equals to CB. Thus, the answer will be 180 degree minus 80 degree divided by 2, and the answer would be 50 degree. As for B, the angle of AOB. The angle of AOB plus the angle of ACB is equals to 180 degree. Thus, the angle of AOB would be equals to 180 degree minus 80 degree equals to 100 degree. As for C, the area of quadrilateral ACBO is equals to, in the triangle of AOC, tangent 40 is equals to 4 over the length of AC. Thus, AC is equals to 4 over tangent 40. And the answer would be 4.767 cm. Hence, as shown in this little triangle, here's A, and there is O, and here is E. Here is 4 cm, right angle, and this is 40 degree. Thus, the area of ACBO is equals to 2 times the area of the triangle AOC. The calculation would be 2 times half times 4 times 4.767, and the answer would be 19.068 cm square. And that's it. Moving on to 8.2, angles between tangents and chord. Here's 2 examples. How to differentiate the tangents and the chords is pretty easy. The shaded one, this one in pink and baby blue, is the segment. Now, if you pay attention, the segment of QBA is an alternate segment to the chord here, and the angle of QBA is equals to the angle X. And for this one, it's the same. The segment QAB of the chord and the angle QAB is the angle in the alternate segment which equal to the angle Y.